Here we're looking at some problems that have to do with perpendicular lines. And remember, perpendicular lines cross each other at a 90-degree angle. So these two lines here, they appear to be perpendicular. One other thing you should know is what a bisector is. And here we've got a perpendicular bisector. A bisector cuts something into two equal parts. So it says here that AB, this line going up and down here, is the perpendicular bisector of segment HJ. So we know that this side and this side are equal lengths, and then we know that this is a 90-degree angle. That's all we really know. Since geometric figures are usually not drawn to scale, A might be a little off of where it's written here, B could be up or down from here, but the things that are locked in this diagram is that HI and IJ are the same length, and this is a 90-degree angle. Now our job here is to figure out which one of these statements is true. So let's look at these one at a time. A says B is the midpoint of segment HJ. And that one's pretty easy to dismiss because B is not on segment HJ, which would kind of be an important criterion for being the midpoint of a segment. I is labeled as the midpoint here. And we know it's the midpoint because there's an equal distance on either side, because this is a perpendicular bisector. B, well, B is actually the correct answer, but we're going to come back to that in a minute. Let me dismiss the other two first. C says BJ, so this line here, equals AJ, this line up here. And you can tell by the way this is drawn that that's probably not true. BJ looks quite a bit shorter than AJ. But you should also think that since this is not necessarily drawn to scale, this B could be really up close here, this A could be much further away. So the difference could be even more pronounced than it is. Let's look at D. Angle HAJ, so HAJ, so it's the angle that would be formed if you drew that. So this angle right in here is a right angle. Well, just looking at this, it looks like it might be a right angle. However, once again, since the only thing we really have locked down are the lengths of these two segments and then that this is a 90-degree angle, A could really be anywhere along here. And think about if you pushed A down, that angle would get wider and wider, definitely wider than 90 degrees. Or if you pulled it up here, the angle would get narrower and narrower, less than 90 degrees. So we cannot say that HAJ is a right angle. We don't have any information that tells us that. Now let's look at B here. AH equals AJ. So this segment right here and this segment. What we have going on is similar triangles, and this side of the triangle and this side of the triangle are the same as, well, this side and this side. And when you have triangles with two sides the same, the third side's always going to be the same. And no matter where A is, I could push it down here, we would have the same thing going on. I could push it way up there, we'd have the same thing going on. There's still two sides the same, so the third side's going to be the same as well. So that one is going to be our correct answer. All right, let's look at one other kind of tricky one here. This one says, which choice provides enough information to conclude that BD, so this ray right here, is perpendicular to BF? And so what they're really saying is that this chunk in here is 90 degrees. What's the information we need to know to prove that? Right now, we don't have any measures of these angles, so they could be anything. It looks like it's 90 degrees right now, but this ray BD could be much closer to the line here, and 2 could be much bigger. This one could be in a different spot. So let's see what information we get here and how we can play around with it. First of all, A says angle 4 is congruent to angle 1. So if these two have the same measure, well, if these two were 45-degree angles, they would add up to 90, and then what would be left in here would be 90, because this whole thing is a linear angle. So if these were 45 and they equaled each other, that would definitely work. However, these could be 44, and this would still be satisfied. These could be 2, and these would be satisfied. So this is not going to be enough to prove that this is a 90-degree angle. Let's look at B. This one's a little more complicated. It says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. So basically, you can think about this. What that would do is make this BE, this ray BE, stay where it is. It's immovable, since this side and this side are always going to equal each other. However, the others you could play around with. So let's say BD was way down here, something like that. Would this 2 and 3, would they comprise a 90-degree angle? Well, no, because it'd be much bigger than that. According to what they're saying, we'd have to move BF down to that same level too, but you could do that, because then, oh no, you wouldn't have to do that, but you could do that, and in that case, what's left in 2 and 3 here would definitely be bigger than 90. So B isn't going to do it either. Let's look at C. It says angle 4 and angle 2 are complementary. That means they add up to 90 degrees. Well, you could satisfy that in a couple of ways. You could say this is 45 and this is 45, and if that was the case, maybe you might make it work. However, you could also say that this is 10 degrees and this is 10 degrees. In that case, this would be down here further. This might be up here further. And that would make that not a 90-degree angle. Let's look at one more. Measure of angle 4 plus the measure of angle 1. So these two equal the measure of angle 3 plus the measure of angle 2. So these two. So the way I like to think about this is all of them, 1, 2, 3, and 4, equal 180 degrees. If 1 and 4 equal 3 and 2, then they have to be half of that. So these two add up to 90, and these two add up to 90, and that's what we're looking for these two to add up to 90. So it looks like D is going to be our answer there. So those are a couple of problems dealing with perpendicular lines.